Okay, use the following to answer questions 9 through 11. The cost of a set of used golf clubs is $640, and golf balls cost $7.50 per box. Well, look at that. $7.50 per box. Sounds like a rate to me, a rate of change per box. So I can already kind of get an idea of what's going on here. We're buying a set of used golf clubs. That costs $640. But you can't play golf, you can't go to the driving range until you have some golf balls to hit. So we buy the clubs for $640, and then we lay down $7.50 per box of balls. So our independent and dependent variables, we need to ask ourselves what depends on what. The cost depends, total cost depends on golf balls, because we initially lay out $640 to pay for some clubs, and then we lay out $7.50 per box. So our total cost is a function of the number of boxes of golf balls we buy. So what I would say here is that the total cost depends on the amount of golf balls purchased. The amount of the number of boxes of golf balls purchased. And so total cost is dependent. On what? It's dependent on the number of golf balls purchased. Therefore, the total cost is the dependent variable, because total cost is doing what? It's depending on the number of boxes of golf balls purchased. So the number of boxes is independent. What function represents this situation? Well, let's see here. If I let y equal total cost, and I'll let x equal boxes of, and I let x equal boxes of golf balls, then I can write y equals $7.50 per box of golf balls, plus, how much did we start out with? $640 plus $640. What is the rate of change? This is kind of review, so that's why we're going through this a little bit quicker. This is exactly what test 4 was all about. The rate of change is $7.50 per box, and the start value, $640. The graph below shows the relationship between the number of boxes of candy sold and the amount of profit made. Profit is the price paid for efficiency. Let's see here. What is the rate of change for this situation? Rate of change. Let's pull out our pen. A rate of change is, remember, when we're looking at a graph here, we can always think of it as our rise, which is the same thing as our delta y, over our run. Sorry for that crooked writing. Change in x. So let's go ahead. And measure that. So let's get a closer look here. Sorry, you get what you paid for. Let's see here. Go to process. Okay, let's take a closer look at this graph here. So it looks like we have profit increasing as the number of boxes sold increase. So, and our goal here is to measure our change in y over our change in x. In other words, our rise over our run. And so, well, let's start here. It looks to be about 25. And our rise, and let's see there, that looks like a good point to go. Our rise would be 5, 10, 15, 20, 25 over a run of 10. So $25 over 10 boxes. So it looks like our profit is $2.50 per box. Write the equation for this set of data. Again, this is a review problem, essentially. Just keep in mind that we need to back this pattern up to 0. What did we start out with? 52. So our starting value we know is going to be 52. Our general form, I'll just put this up here for reference. Our B is going to be 52. Our slope is this change. It looks like it's 8 every time. And the change up here is simply 1. Change in 1, change in 1. So our M is 8x. And the domain and the range, this here is the range. And I'll choose a different color. And this set of data is the domain. Sketch a line with a positive slope. Well, a positive slope means that both the rise and the run are positive. So a positive slope would look something, I'll just draw axes on all of these here. A positive slope could look something like this, where the rise is positive and the run is also positive. Negative slope would look something like this, where our rise is positive in this instance, but our run is negative. Likewise, we could also take a look at a negative rise and a positive run. It doesn't matter which way you go, because a negative in the numerator of a fraction and a positive in the denominator of a fraction is the exact same thing as having a positive in the numerator and a negative in